Okay, so for this problem, we are solving the system by using any algebraic method. So you could use Cramer's rule, you could do matrices, you could do a lot of things, but sometimes we got to look at the equation to see what method should we take. So on this one here, I'm looking to see which one would be the easiest to use to eliminate. So I'm going to choose to do the z's. I could also do the y's because they're similar, and I could do the x's. I'm just choosing to do the z, and you can do any one that you would like to choose. So on this one, I have these two equations here. If I just add them, my z would go away. So I'm going to bring the first equation over. So I have x minus 2y minus z equals negative 6. And then I have 2x minus y plus z is equal to 3. So 2x plus x will get me 3x. Negative 2y minus y will get me negative 3y. The z's will cancel, and that leaves me with negative 3. So now I need a second equation where I have one variable that's gone, the z also, so that I can have two equations that have two variables of x and y, and we can use those to solve for one of those. So I'm looking, I can't use the first two again, so I'm thinking, well, I have a positive z here, I've got negative here, so I need to multiply this equation by 2 to get my z's to have the same number but opposite signs. So I'm going to take this equation and multiply it by 2. So taking this one, multiplying by 2, so 2 times 2 would get me 4x, 2 times negative y would get me minus 2y, 2 times z would get me plus 2z, and that will equal 3 times 2, which is 6. And then I'm going to bring this one on down. So I've got negative x plus y minus 2z is equal to negative 5. Well, 4x minus x will get me 3x. Negative 2y plus y will get me negative y. My z's cancel, and I have a 1 over here. So now I have this equation and this equation that I can use to eliminate another one, another variable. So I'm looking and I see this one and this one. I could easily multiply one of them by negative 1 to get my x's to be eliminated. And I think I want to multiply this one by negative 1 because that'll change more of my signs to positive, which will make it easier later. So I'm going to take this one and multiply it by negative 1. So that'll get me negative 3x plus 3y is equal to positive 3. So multiplying by negative 1, it just changed all of the signs. And I'll bring this one all the way over. So 3x minus y equals 1. My x's go away. I get 3y minus y is 2y equal to 3 plus 1, which is 4. Divide by 2, and y equals to 2. So now I have y equals to 2. I need to solve for x. So I can take this 2 and I can plug it into this equation, and I get 3x minus 2 is equal to 1. Add my 2 over, and I'll have 3x is equal to 3. Divide by 3, and x will equal 1. So now I have x and I have y. I need to solve for z. So when I look up here, I can choose any of the equations, and I think I'm going to choose this one because it has a positive z in it. So I'm going to take my 2x minus y plus z is equal to 3. For the x value, I have 2 times 1 minus my y value of 2 plus z is equal to 3. So this is 2 minus 2 plus z is equal to 3. Well, 2 minus 2, those are just going to cancel. So I end up with z equal to 3. Whoops. So I now have 1, 2, and 3. So I'm going to put those in an ordered pair. They will not always go in a numerical order like that, but I've got 1, 2, and 3, and that's because I have x, y, and z. You need to put them in order of not the numbers, but the variables. X comes first, y will be the second one, and z will be the third one.